And now I am going to get in little more technical, very early introduction. Details of this will be done in chapter 2, where I talk about the vehicle movement, but I introduce the concept of torque, power, speed and energy. In some sense, speed is well understood. Speed is kilometer per hour, speed at which we drive. Some people love to drive at 100 kilometer per hour, others are more conservative, 40 kilometer per hour, depends on the vehicle also, depends on the kind of roads, the traffic condition, etc., etc. Speed plays a very important role. You know, as speed increases, the power consumed increases like anything, not proportionally, not even square, almost cube, just keeps on increasing. We will learn all of that. So, power you understand, you put the accelerator, you try giving more power. What is energy? Well, energy is you keep on using sometime less power, sometime more power, for short time even higher power. If you combine all the power multiplied by the time you use it and integrate it, you get the energy, total energy. That will tell you how much petrol you consumed, how much electricity you have consumed. So, energy is a very, very important component. Torque is the angular force. Torque is very similar to force, except force is you hit somebody, that is a force, but if you rotate and you try to stop, that is a torque. So, it is a force multiplied by the radius of the wheel, that is what gives you the torque, correct. So, well, let us get into a drive. So, basically a drive, engine and motor, engine or motor, engine in a conventional ICE vehicle, motor will generate certain torque and rotation at certain revolutions per minute. Torque will depend on what you need, it will depend on the road roughness, we will get into all those kind of things. If you are climbing, you will need more torque, if you are speeding up, accelerating, you will need more torque. So, it will, the engine and motor has to give you the torque to keep moving, and of course, the rotation speed is measured in, most common measurement is revolutions per minute or RPM. RPM is a very common terminology. Of course, you can talk about kilometer per hour, I will relate this kilometer per hour to RPM. And controller and control torque and RPM, that is what the controller will do, controls the torque and the RPM. So, as I pointed out, the vehicle torque is measured in terms of Newton meter. Newton is the force and Newton into meter, meter comes from the radius. It is force into the radius of the tire. So, that is a torque, of course, which means if you use bigger tire for the same force, you will get larger torque. If you use smaller tire, you will get less torque. So, would come from motor and engine. As I pointed out, our tire is the radius of the tire in meters, and force is called Newton. So, Newton meter. Now, what is this force for? You are moving on the road, so there is called rolling resistance. What does it mean? Wheel is moving, as wheel is moving, the road has time to kind of stop that, there is a certain friction that it applies, rolling resistance comes from that. So, in fact, different kinds of roads will give you different rolling resistance, and therefore, you will require more or less torque. Very smooth road, very good roads will require less rolling resistance, you are going to use less energy. Then what is called aerodynamics. As the vehicle start moving, any vehicle, there is a certain air that hits you, and the air tries to stop you. It need not be, wind may not be blowing, wind may be blowing, may not be, even if it is not, you are moving against the air, that will try to stop you, and that is called aerodynamic resistance. So, these are two resistance stopping you from movement, and you must apply your torque or force to overcome this resistance. Then you want to accelerate, press your accelerator. What do you want to do? You want to increase speed. Now, when you increase speed, again you require torque or a force. You may have studied force is equal to m into acceleration. So, and rotation torque you will do similar kind of thing. So, pickup will require acceleration. The next important reason why torque is required, gradient resistance. So, when you try to move up, you require more force because you are going against the gravity, and that is called gradient resistance. So, combination of rolling resistance, aerodynamic resistance. So, rolling resistance, aerodynamic resistance, acceleration and gradient is resistance is the resistance that is offered, and the torque has to overcome that. Okay. Vehicle speed, as I told you, vehicle speed that we are used to is kilometer per hour, defined by motor engine revolutions per minute. So, revolution per minute and kilometer per hour. How is it related? It is a very simple thing, that speed is also given instead of kilometer per hour, basic speed is very often done in meter per second. Now, what does it mean? Instead of kilometer, you have put a meter. So, actually the speed you have to multiply whatever you get for kilometer per hour by 1000 to get the meter. But hour, instead of per hour, you are trying to do per second. So, an hour is 3600 seconds. So, you only are multiplying in kilometer per hour by 1000 times, you are dividing by 3600. So, essentially if you want to convert the speed of meter per second into kilometer per second, what you have to do is you have to multiply by 3.6, or you divide the kilometer per hour by 3.6 to get meter per second. So, if you are driving, let us say at 80 kilometer per hour, how many meter per second? You divide by 3.6. So, approximately 23, 24, 25, approximately 25 meter per second. That is in 1 second how many meters you are traveling. Okay. Now, what is that equal to? Meter per second, RPM, revolutions per minute. But revolutions per minute is revolutions per minute. I have to convert it into what is called radians per second. So, to revolutions I multiply by 2 pi to convert radians, and then I divide by 60 because per minute is converted to per second, and then tire radius I put it in meters, whatever 0.5 meter, 0.6 meter. This will give me the speed in meter per second. Now, remember 2 pi I have to do because finally you are traveling 2 pi r. So, 2 pi into radius is the distance that you are traveling. Linear speed is 2 pi r, and per minute into per second. So, you are doing per 60. So, this if you compute it is RPM and you convert 2 pi by 60, it is approximately R tire by 9.55. Very often at a very rough calculation you do tire in meters divided by 10, that gives you approximate. So, in kilometer per hour you will get 3.6 into RPM into R tire by 9.55. You will have to use this. This is a slightly sometimes, it is a unit conversion, you have to use this quite often in the course. And as I pointed out, power is in watts. Power that is used, the unit that is used is watts. Watts is 1 Newton multiplied by 1 meter per second, force multiplied by velocity. And since force is torque divided by R tire and velocity is RPM into R tire by 9.55, the R tire cancels, actually it is power in watts is torque into RPM divided by 9.55. So, you just take torque and in Newton meter and you take RPM, you do not even have to worry about RPM kilometer per hour and just revolutions per minute, and just multiply them divided by approximately 10, 9.55, you get power in watts. Okay. And power in kilowatts will be 1,000th of a power in watt. So, that those unit conversions you will have to do very often. Now, the next important thing is there is gears used. All of you must have heard of gears. You normally do manual gear or there is automatic, and if you go from one gear, what does a gear do? Actually gear multiplies the torque. So, the torque, you get certain torque and you want more torque. You put a gear, so it actually, depending on 1:2 gear or whatever you have taken, the torque gets multiplied by a factor n. So, as a result you can get higher torque. So, what is called low gear multiplies by larger value of n. So, when you are climbing up, you want to need more torque, so you go into low gear, you are able to get more torque. So, n becomes larger. In high gear, when you are cruising, you do not require that much torque. If you are not accelerating, then n can go to small value. Okay. So, vehicle torque is n into motor torque. So, whatever motor torque is or engine torque is, you can multiply it by n times. But you never gain, this is one law of physics, you can never gain something without losing somewhere else. So, you are multiplying. So, gear, what does it do? It actually, when you are rotating one time, multiple times rotate by one time, that is what multiplies the torque. In RPM, the number of revolutions per minute will go down. So, speed will go down, but you very often do not care. When you are climbing up, speed can go down. So, it divides the RPM. So, vehicle RPM is engine or motor RPM divided by n. So, now remember motor and vehicle. If there is no gear, motor RPM is same as engine RPM, vehicle RPM, and motor speed is same as vehicle speed. But if there is a gear, you have to multiply torque by n and you have to divide the speed by n. So, you have often seen at gear 1, you are climbing up at slow speed. Whenever you climb a ramp, you have to do that. When you are cruising and not accelerating, you can go to gear 4, the smallest gear, and now you are getting you are not accelerating, you are getting a decent speed, but your torque is small. And we will learn all of this. Why do you require less torque while cruising? Why do you require more torque while climbing? While accelerating, why do you require more torque? So, all these things we will learn. This is simple vehicle dynamics, we will learn this. Remember, while torque gets multiplied, the RPM gets reduced by the same factor. So, power remains same. Finally, you cannot generate power, you cannot lose power. Of course, power goes down by a small amount, to the extent that gears are not 100% efficient. They are fairly good, 98, 90, but 97, but few percent of the power will go. So, in engine or motor torque may be multiplied at the expense of engine or motor RPM. Now, this is a must for IC engine. IC engine has to have gear. Now, you can have manual or you can have automatic. Why? Because IC engine cannot drive very high torque climbing up, as well as cruising torque. It cannot give the range. Motor, good motors can give you the range, and therefore gear is not required, or what is called a fixed gear is used, just a fixed gear, whereas a petrol vehicle has a gear which keeps on changing. Now, it may be changing manually or automatically. Till about 25-30 years back, it was only manual, but now it may be automatic. And automatic may not be as efficient, that is a different issue, but it has to have gears. Electric vehicles, as you go forward, will have what is called a fixed gear, a single gear. It will not change. It will change the motor torque and speed accordingly, from very high torque to very low torque, and very low speed to very high speed. That is possible, and Kannan is going to deal with this in the course. So, as I say, do you use multiple gear or changeable gear? Multi-gear or changeable gear can change gear ratio. So, the N can keep changing, that is what happens. Gears, what is done? So, basically the clutch is used, there is, if you are manually doing it, you need a clutch, you press the clutch and the gear disengages, you change the gear, another gear and engage it again, remove the clutch. That is what is done, common in all ICE vehicles. EV have fixed gear, as I pointed out, and therefore less and less. There are some changeable gears once in a while. For example, I have been driving electric vehicle, it has a one gear for really high torque, but because my vehicle was designed about 5-6 years back and motor is still does not have the range, but newer vehicles will have motors which may not require any changeable gear. So, while driving I do not have to, but just to start I may use a separate gear. So, fixed gear is becoming more common. Remember, power does not change with gear ratio. To sum up, vehicle performance parameter is torque, speed, power. Torque in Newton meter, speed in kilometer per hour or RPM, and power in watts, determined by either IC engine or EV motor. Gears can multiply torque at the expense of speed. There is another thing that I want to introduce, we will find it useful later on. Very often for motor or for engine, you will talk about what is called normal values and peak values. Particularly for motors, it becomes very, very important. Normal value is what is sometimes called nominal, continuous or cruising value of torque, speed and power. Peak value is used for a short period of time and you can go very high torque or very high speed and power. Now, particularly it is extremely important for electric vehicles. Why? Because it is possible to go for very high torque. Even if the normal torque is like this, you can actually go almost 2 times the torque. Motor does not prevent that. But what happens is that whenever you try to drive motor to high torque, to any torque, a certain amount of heat will be generated. Basically, motors are never 100% efficient, though they are quite efficient, 94%, 95%, 96%, then 4% heat will be lost. Similarly, the controller, there will be heat generated. What happens to the heat? That heat has to be removed, because if heat is not removed, then the temperature of that, let us say electronics, will keep on going up and up. Similarly, motors temperature will keep on going up and up, and above a certain temperature electronic components will start failing, and even some of the motor components will start failing. So, you have to extract the heat. So, motor is designed for what is called nominal torque, speed and power. You can run it continuously at those torque, speed, and it has enough heat removal capability to remove all the heat generated. Peak time, you use it for very short period of time, 5 seconds. You are driving, somebody is ahead of you, you are trying to drive in a highway at 60 km per hour, and this fellow is driving at 40 km per hour and is not giving you space. You are like to speed and overtake. That will take 10 seconds. You accelerate like this. That for 10 seconds it can give you the higher torque. More heat will be generated. It will not be taken away. It is not called thermal equilibrium immediately. In a nominal situation, it is in thermal equilibrium. Temperature remains constant. So, temperature will go up, but that is for 10 seconds, and now after that you have gone back to this, the heat dissipation, heat generation will go down, and gradually the extra temperature will go back to the nominal. So, remember, peak values cannot be used forever, and the prime problem is thermal heat. Okay. Want to end by how will you specify motor and controller? It will be done in detail by Kannan. So, we will have to derive from vehicle parameters. What is vehicle? What is the speed that vehicle wants, and what is the gear ratio that you want? Because finally you want a certain vehicle speed, vehicle torque. Motor specifications are therefore derived from the vehicle performance, and from there a certain, you want a certain torque and you want a certain speed, and you derive what is called torque speed. And then of course you have to worry about nominal torque and speed and peak torque and speed, as I have already described the difference between the two. Similarly, you have to worry about what is the power that you require, torque into speed, what is the power, and again you have to talk about nominal power or peak power. Okay. And then the other important thing for motors is thermal. Some components like magnets in a motor are impacted by higher temperature, most other things are not. So, you have to worry about what is the thermal, what is the heat generated, how do you remove heat. In a nominal situation, peak should be for short enough period, so that does not matter. And of course, you have to worry about mechanical, what are the vibrations that will be involved, what is the size, weight, etc., cost. All these things basically tries to specify motor and controller. So, there is a home assignment that I am giving. There are lots of periodic home assignments that will be given. Some of them will be very straightforward, almost oral, some will be little more complex, and the first one that now after this lecture you are capable of doing is assume a vehicle has a wheel radius of 0.3 meter, convert the speeds of the vehicle at 1000 rpm into kilometer per hour and meter per second. If it is a 2 meter per second speed is there, then into kilometer per hour and rpm, whatever I had taught you. So, this is the end of the first section of chapter 1A, first section introduction and second section. Any questions?